Hello. Today we're going to be looking at elements, what's called molar mass, and some mole conversions. So in the lab we talked about a dozen mass, the mass of a dozen things, whether they be cotton balls, corn particles, rice grains, a dozen of objects, right? But molar mass, well, what's a mole? So a mole is a very large number, 6.0 times 10 to the 23rd particles. There's some more chemistry and physics and ancient history to determine why this number is what we call a mole, but let's just roll with it since this isn't much of a history class, and we want to be able to do the calculations that we're going to be doing later. It's so big, though, you really can't fathom it. Humans actually have a tough time understanding things over 100, to be honest. So let's just think of this as a relationship, okay? Just like a mole is a dozen, a dozen is 12. A mole is so many particles. So it's a very large number, but how is it connected to mass? Well, when we have a mole of particles, for let's say oxygen, it will equal its atomic weight in grams. So this many particles is equal to this many grams of oxygen. Different elements have different atomic weights, so they're going to have different masses as well. But it's the same number you find at the bottom on your periodic table for every element. So that's going to be a useful place to come by. So we're going to be utilizing this relationship and this relationship of molar mass to 1 mole for this lesson. So looking around, there's what's called a mole map, essentially what you would use to multiply or divide in order to get yourself from moles to grams, moles to any type of particle. And we say particle because they could be atoms, molecules, formula units. These are used with elements that are by themselves, so monatomic elements, just atoms. These used with molecules, where there are diatomic elements, which are molecules because they're two atoms bonded together, larger things like CO2, H2O, fancy stuff, but covalently bonded. And then these are for ionic compounds. They're units of the chemical formula, NaCl, H2, SO4, all that kind of stuff. And if we needed to go grams, we need to go with 2 conversion factors. We'll be using the dimensional analysis method that we talked about and showed with things that were commonplace objects. So now, just like any sandwich, it's not complete unless it's all together. So we can use the idea of a mole and molar mass to take the amount of grams of elements and compounds to an amount of particles. We call science, not math. So you're going to use these relationships, and I want to show you how you can do this so you can demonstrate proficiency, i.e. get the 3. So that's what we're looking at doing here today, but it piggybacks on the dimensional analysis practice we've already done today, or done before. So let's take a look. So some examples of conversions. We're going to start off with elements, and we'll get to something later, and we'll look at compounds and so on. So when we have something of a mass to moles, that's going to be 1 step. Even if you don't know it to be 1 step, I want to walk you through the process of how we get here. So we want to start off with our value provided, our value given. And we want to put at the other side what we're trying to find. Just like when we think of a roadmap, we want to get from where we start to where we end. And if we don't write where we end, we often get lost. Now you can see grams is where we start, and we're multiplying it again, just like in dimensional analysis, with a fraction, a ratio, whatever you want to describe it. But you can see grams is on top. The grams value needs to go on the bottom. And again, masses come from our periodic table. So we would take this Cl2, and because it's diatomic, we'd multiply it times 2. So chlorine's 35.45 times 2, 70.9. And this is a ratio to 1 mole. Based upon where it's at, you can see because this is on the bottom, I'm going to divide 10 divided by 70.90 to get my 0.141. If we're going moles to grams, it's the same concept, only in reverse. So moles I start with, because that's our value, and we have so many grams that we're trying to find, right? We don't know how many so far. We still use the same ratio of mass to moles, and you can see I can put it either one on top. It doesn't matter. Just like if I had a ratio in my class of 7 girls to 9 boys, or 9 boys to 7 girls, it doesn't matter which one I put first, the ratio still holds to be true. So I see moles on top, moles on the bottom, and again, right now it's per mole, so that means 1. While our molar mass of barium, you look on the periodic table, 137.33. I can see it's on top, so I'm multiplying everything here to get my 934. You might say, well, why is it 934? Why isn't it something else? Well, significant figures, which we talked about a long time ago, are going to really dictate what we start off with. So we start off with 3 sig figs, we're going to end with 3 sig figs. Started with 3, end with 3. Just because that's the way it's going to go. Now, if you don't get significant figures correct, that's okay. That's not part of our standards. But I'm just trying to teach you science, of course. Now, when we go from moles to atoms, we're going to use a different conversion factor. That is our ratio of particles to moles. Again, I'm starting off with how many moles that I know I have, and trying to find out how many atoms that I'm trying to currently look for. So again, moles go on the bottom, it's per mole, and Avogadro's number, or of 1 mole, goes to particles of calcium. All of these units and descriptors like calcium and barium need to be written in order to get 3s. So get practice starting it so you can do it proficiently on the test. The last one down here, if we're starting off with atoms going to moles, I have my number of atoms on the bottom, which has my Avogadro's next to it because that's what goes next to particles, with 1 mole on top. Because I see it's on the bottom, I'm going to divide. If you're not going to get this value on your scientific calculator correctly, it's probably just misuse. I'll show you again how to use any kind of calculator for scientific notation. They're usually built for it. On your phone and stuff, it's different. I really suggest that when you're in class and get practice, use the scientific calculators I have, because that's what you'll probably use on the test, and you need to understand how to use those. So far, we've just been looking at going 1 step. As you can see, all these have 1 step each, but that's not the bare minimum that we do. That means we need to go 2 steps. Now I go from mass to molecules, or particles to mass. That's a 2-stepper if you remember back looking at our mole math. If I'm going from here to here, or here to here, I have 2 steps I need to go with. Let's go back. So I'm starting off with my mass of molecules. Then I'm trying to find my number of molecules. So again, I follow my units. Mass is what I start off with, so I need to use molar mass. The mass goes on the bottom, moles on top, so I can cancel these units out. Now I have moles on top. I need to get to molecules. You think of, do I relate moles to molecules? Of course you do. Avogadro's number. So moles on the bottom, molecules on top. And so then I have my setup here, and I need to think of my math. You multiply everything across the top and then divide by what's on the bottom. Again, since there's only 1 on the bottom, you can ignore it. So 10 times this equals a value divided by 70.90 gives me my 8.49 times 10 to the 22nd molecules. I always invite you to do this yourself on your own calculator and make sure that you can get this exact number, because otherwise you're going to be wrong. And why be wrong when you set it up correctly? Same idea, just the other direction. So starting off with my number of atoms. Atoms would need to go on the bottom to cancel. Avogadro's number goes with this unit. Mole goes with 1. This is our molar mass. Moles go from here to here. They're going to cancel out. Again, 1 mole has so many grams per lithium. This is 3 sig figs, even though it would have rounded to 2. I just put this here because, again, not worried too much about sig figs. I want you to make sure you get this rounded value. But again, multiply what's on top, divide by what's on the bottom. And again, if you're getting some really, really large number, you're using your calculator wrong. Again, I'd be happy to show you in class how to do it properly. It's not hard. You just need to do it correctly. So if you're interested, this is kind of a walkthrough for things when doing all this, not using a compound, but this doing just regular atoms. Again, if this was going atoms to grams, really walks you through all of it. So if you wanted to read through it and pause, and some of you work better that way, the big idea is that you have your units get canceled out in order to get to the final unit that you have there. And the values go next to the units, which is why we get there. Same all the time, different units, different setup procedures. So again, your units are telling you how far to go. Just like if you were traveling around town, the streets will tell you when to stop because, well, I only need to go as far as El Costa, so I'll stop. All right, come in with any kind of questions and talk to you later. Take care.